I'd like to introduce Eric Knapp. And Eric, if I can have you share, I really appreciate having you again.
Dale asked me to come up and talk a little bit about long-term maintenance of masticated fuel beds, and I'll share some of the work I've been doing with various collaborators. So just various projects I've been doing with other folks, other scientists at the Pacific Southwest Research Station, also with Humboldt State University and Mississippi State University. So, I mean, probably this isn't an introduction needed by this group, but mastication is, in other parts of the country, it's known as mulching or chipping, and it's oftentimes used as a treatment in areas where other treatments are hard to implement. And it's become a pretty common tool to use around here. But one thing to understand about it, it's not really fuel reduction, it's a fuel rearrangement treatment. And I will, so kind of an overview of what I'm going to talk about in this talk is just a little introduction about how mastication works to alter fire behavior, some of the pros and cons of mastication, and then I think one of the best ways to learn about what it can and can't do is to actually look at instances where wildfire has burned into areas that have been masticated. So I'll share some pictures of that. And then one of the issues that Dale asked me to talk about is, well, how do you maintain these treatments in the long term? So we'll talk about that a little bit. And kind of the key from the standpoint of longevity is to understand how fast the woody chips break down and decompose. It's oftentimes assumed that once you put those chips down by the ground, that those decompose fairly readily. So we'll look at that, and then how fast do the shrubs and the other vegetation you're masticating, how fast does that grow back? So I'll talk a little bit about how factors that increase longevity of treatments, and then say a little bit something about prescribed burns in masticated fuel beds. So just kind of an overview of you know, when you have the kind of fuels you have around here, these volatile fuels with high canopy bulk density, it's not uncommon to see fire behavior off shrubs that look something like that. And the way to think about how mastication affects fire behavior, it's sometimes useful to think about the fire triangle. And of course, in order to have combustion, you need fuel, you need a heat source or a spark, you need oxygen. And so in the case of mastication, if you take these shrubs and you grind them up, chop them up, drop them on the ground, you haven't changed this part of the equation. You haven't changed the amount of fuel. You still have a heat source, but what you've done is you've changed the oxygen. You've changed how the fuel bed is oxygenated. By flattening the fuel bed out, you have a much more compact fuel bed, and there's not as much oxygen in it. And so what we've found is that this reduces the rate of fire spread. And the way it does that is, and then it also reduces the flame length, because you have the same amount of fuel consumed, so the amount of heat, total amount of heat released is the same, but it's being released over a longer period of time, so the flame lengths are shorter. So that's basically kind of a summary of how it works, at least in theory. And so I have a collection of pictures here of how it actually works in practice, and I hope everyone can see it. The screen's a little low. But this was a fire that burned on BLM land near Reading, and these are areas that were masticated around a gun range there, and so they have common fires when bullets hit the overhead power lines or something, and yeah, it's a problem out there. But here's an unmasticated area and a partially masticated area in the foreground, and you can see there's some leaves remaining on the shrubs in the foreground, so it might look that there was a difference in fire intensity from the hillside here to the masticated area, but it's also up on a slope and fire moves faster uphill. So I'd say in this particular case, it wasn't really clear how mastication affected fire behavior, but the masticated areas were used for line construction. They were used for retardant drops. So it was an effective fire management tool. And this is another fire, the Boulder Complex lightning fire on the Plumas National Forest. And in this particular case, we had a backing fire that came through a unit that was masticated like only a month before the fire. In fact, I think the masticator was chased out by the fire. And so the fuels may not have even fully cured yet. They also maybe didn't fully, weren't compressed by a previous snow. But again, this is an area where fire line was constructed and the fire was caught in a masticated unit. But when you look at the effects on the surrounding trees, you can see, well, I walked around and I could look at the scorch height, and it was about the same in the masticated unit and outside of the masticated unit. The same amount of fuel was consumed, so that's kind of what your expectation might be. This is another fire, and I think it's probably interesting from a homeowner perspective. This is an area in the Tahoe Basin that was masticated around homes. And the Angora fire gets all the attention, but this happened about a month and a half after the Angora fire. And this is one that burned only 10 acres, but it took out 5 houses. And so here is what the masticated area looked like adjacent to the fire. And this particular fire was a heading fire. It was heading uphill from down here up. And the firefighting crews on this fire, they reported a slower rate of spread, as we would expect. And it helped fires contain the fire. They were able to jump and deal with the houses in the vicinity, and they knew it was going to slow down in the masticated unit, so they were able to put the resources where it needed to be at the time. But you can see the heat killed most of the overstory trees, so it still produced a lot of heat. And you can kind of see it wasn't a crown fire, and you can get a pretty good clue of what the fire behavior was like by looking at the char height. Usually the char height on the bottom side of the tree is approximately equal to the flame length. And so in this particular case, you may have had like 5 or 6 foot flames coming through this unit, but that was enough heat to kill the trees. It only takes 140 degrees to kill the needles of a tree. And this is a fire from last summer, the Carson's fire down at the Stanislaus. You folks in the back of the room probably know this one well. And this is some pictures that were given to me by Shelley Crook from a Forest Service report. And so in this particular case, they created a fuel break along this ridge, and they masticated this little spur coming down here. And the fire came through here, and so she had a lot of side-by-side comparisons of masticated areas. This was masticated here, this was the same area unmasticated. And you really don't see a whole lot of difference in the outcome on the vegetation looking after the fact. And so she went back in and looked at what the areas looked like just outside of the fire perimeter. And you can see this is a masticated area, and here too. It was masticated in 2009, so it had 4 years to come back. What they reported here was easier line construction, slightly reduced rates of spread. Cons of the treatment is in her opinion, the added dead fuels increased the fire intensity, and it made the fire harder to control in areas where it got into the masticated fuels. And her observation was this was masticated pretty coarsely, as you can see here, and pretty large particle size. And her thought was that by not putting that fuel down against the ground, it was less likely to decompose, and so it possibly had a reduced effect on fire behavior than you might expect if you had that fuel crushed into smaller particles. So I think this picture basically tells the story, and this is one that the fire folks there sent me. This is an area on the ridgetop in a masticated unit, and you can see that they've used the masticated unit to create a bulldozer line, and then they did a burnout operation in the masticated unit against this dozer line. So you can get a sense that there's still quite a bit of heat produced by the masticated fuels. It was useful for fire management, but you haven't changed the total amount of fuel. You've just laid it on the ground. And so that kind of illustrates, I think, some of the pros and cons of so just kind of summarizing how these masticated units performed under wildfire conditions. I would say the results are mixed. You have to understand what you get with that treatment and what it's good for. So there's a lot of examples where it potentially aids in the firefighting by lowering the rate of spread and just making line construction easier, making access easier. But you have same or similar amount of fuel. This is drier. You've converted a live fuel to a dead fuel. Oops, sorry. And if any of you have ever burned shrub fuels in your stove, you know it has a high heat content. So that wood on the ground, it puts up a lot of heat. And therefore you have a same or similar effects on vegetation. And a lot of areas that mastication is used are stands that are fairly young. Like it's oftentimes used in plantations where shrubs have come in. And so your trees tend to be fairly young, and you just have to understand that you oftentimes get high mortality if you consume a lot of fuel in an area where your trees are not very tall under wildfire conditions. You may lose them. Even if you've changed the intensity of the fire, it can be intense enough still after treatment that you lose the stand. So it's not necessarily a treatment that increases the resilience of your stand to wildfire. And I think that's something that's important to understand about the treatment. So just some other considerations, that even with the mixed results, it's still an important tool because there just aren't a whole lot of options in our challenging fuel scenarios. It's a very tough type of fuel to manage, especially if you don't have, say, in areas where the fuels that are causing you a problem don't have any commercial value. So, and also around houses where maybe fire is difficult to manage. So it's a tool in the toolbox, but it's also costly. And one of the concerns about it is well, how long do the benefits of mastication, how long does that last? And so the next couple of pictures I'll show are some examples of how masticated units look over the long term. So first, say something about what we might think of in terms of success in the long term of a masticated treatment. Well, over the long term, ideally you'd want to reduce the availability of dead and down fuels for combustion. And I think it's often assumed by putting that fuel on the ground, it will decompose and then become unavailable for combustion. It will become part of the soil. So you remove it from being able to fuel your fire. Another thing with mastication, you're slowing the rate of vegetation development. Or one other possibility there is by treating these fuels, you're hoping that you're perhaps promoting a vegetation that has a lower fire hazard, moving the vegetation into something else that doesn't cause you as many problems. But really, in order to not build up the fuel in the system over time, to be successful, the rate of decomposition or fuel removal has to be greater than the rate of regrowth. Otherwise, you're just on a cycle of just increasing the amount of fuel in the system. So just thinking about that in terms of, here's a few treatments. This particular site is on the Mad River fuel break on the Six Rivers National Forest. And this picture I took 13 months after a mastication treatment. And then I went back to the same fuel break 9.5 years later, and this is what it looked like. And I was pretty amazed. When I came there, I expected to see a wall of manzanita, and so you have to think about, well, what was masticated here, and what happened? This manzanita here happens to be a seeding shrub species. It doesn't come back. Some shrubs come back really strongly from the cut off stems. Some have to come back from seeds. And then it was white leaf manzanita, and this was quite a substantial mulch fuel bed. And so my thinking here is that this suppressed the seeding species from getting established. And you can see some of them did get established. There's some plants here. I also think that in this site there was a heavy browsing pressure. And I think this ties in well with the next talk, but I think the browsing here was, this was Bambi. This was no goats. This was what happens. I didn't realize, I didn't really think about this beforehand, but if you masticate a small patch of a small fuel break in an area composed of shrubs, where does Bambi go? Well, out of the openings. And so I think this had really heavy deer pressure, and I've heard that deer don't even really they don't prefer manzanita at all, but these were all pretty heavily browsed back. So another thing to look at though here is after 9.5 years, that wood is still very much on the ground. It's still a factor. So that's one extreme, and then on the other end of it, here's a site on the Klamath National Forest where a vigorous resprouting shrub, snowbrush in this case, was masticated. And I took this picture here 1 month after mastication, and then here's one of my collaborators, Morgan Barner, standing in the same area 14 months later. It's up to his hips. So this is a very vigorously resprouting shrub. And so you can see that the longevity of the treatment is going to really strongly vary depending on what you masticate and what the shrub composition of the community is. Here's an area in Whiskeytown National Recreation Area, and this is kind of an intermediate to the last two. This is an area that contains a mix of seeding and resprouting species. And so what I thought by masticating, by looking at those previous two pictures, you would expect that you'd see a shift to more of the resprouting species. And that's indeed what you see. In some of these units, you have a lot of poison oak coming up. That seems to really thrive. It comes back strongly. Or this toyon, or the yerba santa. But you also see a lot of seeding species. Like this is knobcone pine, and some manzanitas come back. This is 11.5 years after mastication. The wood is still on the ground underneath the shrubs now. So the wood's still there, the vegetation has come back. So that's a problem. So again, this is what the wood looked like. I took this picture on Monday, 11.5 years after mastication. That wood is still there. And I think we're actually going to do a study this fall, actually go back to the sites that we looked at and quantify how the amount of decomposition, the amount of shrub regrowth. So this is just sort of an observational thing at this point, but I think it's safe to say in a lot of the sites that wood is perhaps not decomposing as readily as we might want. And I think a lot of this has to do with our climate in California, that Mediterranean climate, where this is a graph showing rainfall, I guess average rainfall, not this year. This would be flat. But this is Reading rainfall, and you can see every month, then what do we have in the summer when it's hot? Almost no rain. Well, in order for decomposition to occur, you get the most decomposition if your hot period coincides with your wet period, if you have summer rainfall. Here it's bone dry in the summer, so we don't get a lot of decomposition. And so, in a way, we have the perfect storm in our environment. This explains why it's such a challenging area to manage fuels, is we have a high fuel accumulation environment because we have a lot of precipitation. It grows a lot of stuff. Yet, it decomposes slowly because it is hot at the time of the year where it's dry. So, what are some factors, what are some things we can do to aid in the decomposition? Well, one of the thoughts is that if your masticated fuel particles are small, they're more likely to break down. And you can change the size of the masticated particles by masticator effort. And I've seen some machinery going through where they're basically just pushing shrubs down rather than spending time chopping things up into small pieces. There's also the machinery differences. The rotating type heads tend to produce bigger chunks than, say, like the drum type or flail type heads. So there's differences with machinery and the size of the chips that you end up with. And also, and that affects the contact with the soil. The smaller the chip, the more it compresses into a compact fuel bed. I've also seen, when we've tried this experimentally, is people actually tilling the material into the ground to increase the contact with the ground surface, and thereby speeding up the rate of decomposition. Also, obviously, precipitation, especially summer precipitation, matters. We don't get a lot of it here. So what about regrowth? I think from the pictures I showed, it's clear that you have to really consider the species that you're working with in terms of how long that treatment is really going to last. It's probably a treatment that lasts longer when you're dealing with seeding species than you're dealing with vigorous resprouting species. And in terms of reseeding, the amount of mulch or the masticated chip depth matters, and I have a slide of that next. Productivity of your site, rainfall, that's something we can't do a whole lot about. And retreatment and herbicides, retreatment with mastication or herbicides. That's one way to knock back the vegetation too. But there's other trade-offs there. There's other problems. Cost. Herbicides are not popular in some parts. So there's challenges with using that. And I think one of the things we have to consider too is overstory cover. A lot of these shrubs are limited by overstory cover, and if we can grow the overstory above these shrub areas, that you can do some of that more cheaply instead of having to constantly retreat an area, and I'll share a slide about that as well. So just kind of showing you that we visited 10 sites in Northern California, and we took some data. This is now about 8 years ago where we did this, and we have one site that's just up the Everett Memorial Highway. It's just right in town here. That had some of the lowest fuel loading of the 10 sites we visited, and then here's that Mad River fuel break again, where you have that deep layer of masticated chips. And one thing you can notice here is the chip layer, and it can be both a plus and a minus. If you're interested in suppressing the shrubs, like here, it looked like it was effective at limiting the amount of reseeding of shrub species. But if you're interested in, say, like the grasses and the forbs and restoring some of that component, they don't do as well in a heavy chip layer. And you can see in this area, in the Mount Shasta site, where we had fewer of those chips, you can see some grasses and forbs coming in the foreground. That wouldn't have been possible down here. So you also see here at this Mount Shasta site, we have a vigorous re-sprouting manzanita, so that comes back real readily as well. So what about overstory cover? This is a site down on the Challenge Experimental Forest out on the Plumas National Forest. And this is an area that we treated with mastication, and then we followed it up with a prescribed burn. And that burn, it stimulated just thousands or millions of shrub seeds to germinate. And so that ground was covered with shrub seedlings after the fire. But it was really interesting to come back last summer and see where these shrubs persisted. And you can see, here's one of my collaborators standing out in the shrub field. In the openings, these shrubs are going gangbusters, but where you have trees, it's much more wispy, and when you have the denser overstory canopy, what I've noticed is that the shrub seeds will germinate, and they'll basically die in their first year. If they don't have enough light, they just die. So in this particular case, by creating canopy cover over the top, we have converted it into a fuel type that's perhaps less volatile. And so that's just something to consider, is using what you have to manage your understory fuels. And I think sometimes, like in these plantations, the thought is to sort of release the trees to get them to grow faster, to be able to eventually shade out the shrubs and sort of hasten that process along. So I talk a little bit about prescribed burning in masticated fuels. I think in areas where the wood does not break down as readily as it does in where we would have summer rainfall, ideally mastication is not a standalone treatment, but maybe something, you consider it as something that will help you introduce fire, because you need a tool to deal with that, the wood on the ground. And obviously, That's not going to be something that you can do in all areas, but it's certainly something that has probably been done less than it could be. And, and there's obviously concerns like smoke management, risk, liability that limit the use of fire. But there's also sort of biological concerns, and those are things that we thought we could address to at least take those off the table if we knew something more about it. For example, a lot of areas where are masticated, the trees are fairly small, and there's a concern that if we put fire into these units that we're going to kill those trees. So that's one thing we were looking at. And also with the layer of shrub wood on the ground, there's some concern too that of soil effects, that we're going to just push a big pulse of heat into the soil and cause some damages that way. So we did some experiments on that at 2 of these sites near Whitmore and down by Challenge. And these are 25 to 40-year-old ponderosa pine stands with brush. And it's really nice to see Dave Cook in the audience because I think he lit this fire. Remember that, Dave?
Yes.
Did you get poison oak?
No.
Good. Yeah, this was quite a sight. But yeah, it was really great to work with Dave burning one of these sites. He's a great burner. So one of the things in looking at fire effects on trees, you can kind of see the problem here. We have all this wood on the ground. We got this very spindly looking ponderosa pine tree. And the thought was, well, we're going to kill these things unless we do something about it. So what we did is we randomly selected a bunch of trees, and we raked the fuels away 1.5 feet from the base of half of the trees. And you can see here the trees after the fire that we raked. So what happened? Well, 18 out of the 65 raked trees died, and 23 out of 66 unraked trees died. No statistical significance. It wasn't enough of a difference to say that we affected it with raking. So what's going on here? What we did is we measured a whole bunch of other things, and we measured the diameter of the trees, the charring of the stems, how high up it was charred. It gives you an idea of the intensity. Percentage of the crown volume that was scorched. Trees usually can withstand about 60–70% of the crown scorched before they start going downhill. And this is just the probability of that factor being important. As you can see, the 2 factors that really came out, both at Challenge and Whitmore, were diameter of the tree, which is pretty obvious. The smaller the tree, the more likely it's going to die. And the percentage of the crown that was scorched. The char didn't seem to matter so much. Even these small trees, the bark was thick enough that it withstood that heat from the masticated fuel, which was kind of eye-opening to me. So it's possible to put fire back in these stands if you can manage the scorch, apparently. And this is kind of a value that looks pretty high here, 35% mortality at Challenge, but there's a story behind that. All that mortality was in the first unit we ignited, and it was because we didn't calibrate our ignition to the kind of fuel. Using the same sort of strip ignition, the same width strips, and there's a lot of heat in that fuel. So after the first unit, we thought, it's like, wow, that's a little hot. So the next units, we used a little more backing fire, just were a little more gentle in how we put it through the stands, and we had mortality much more like that. That's how many trees you killed, Dave, 7%. And they were, mostly the small, pretty unhealthy trees that you'd want to thin anyway. So it looks really great. Those sites look excellent after those burns.
Right on, Dave.
Yeah. So on the soil end, we did a little experiment just behind our Reading office, and what we did here is we looked at how heat goes into soil, and so we actually took these PVC pipes and we collected these cores by hammering it down into the soil, and then we took them into the lab and we wetted them up using we wetted them up in the lab to field capacity to dry and everything in between. And then this is one of my employees here sticking a temperature thermocouple into the middle of that soil. And so here's the temperature measuring device. And then we backfilled the trench added a bunch of masticated fuel to it, and lit them on fire. And so this is what we found. This is the degrees in centigrade here, and this is the time after ignition, and here's sort of the heat pulse into the soil. 10% soil moisture, or bone dry. Look at that heat pulse. Whereas 20, 30, or 40%, much less heat into the soil. What's our critical temperature of where you kill the roots is about 60 degrees centigrade or 140 degrees Fahrenheit. That's right here. And you can see there was, with bone dry soil, we put a pulse of heat down 1 inch for 8 hours. But when you had a little moisture in the soil, that moisture in the soil dissipated a lot of that heat, absorbed a lot of that heat energy. So we didn't put a lot of heat into if we just had the soil a little moist. And that's the typical condition you have, say, in the spring here, when after the rains or after the snowfall, when things are starting to dry down, but things aren't totally dry yet. You can have that in the fall too, if you time it right. So just validating this out in the field is we also put a bunch of thermocouples in those prescribed burns we did in at the soil surface right underneath the masticated fuels, and this is the fuel load above the thermocouple, and so you can see, pretty high temperatures at the soil surface, but did it get into the ground? These are 1 and 2 inch depth in the ground, and again our lethal temperature. So no matter what the fuel load in our site, at every one of those thermocouples that didn't reach the 60-degree threshold. So by burning in the spring, we didn't push a pulse of heat deep into the soil. And so this is my collaborator Matt Bussey did this part of the work, and what he concludes from that is that there's few worries in all but the driest soil conditions, and he just suggests that to burn when the condition, for best effects, burn when the soil is still somewhat moist. So just to kind of wrap up, not really conclusions, but just kind of the main points of what I've talked about today is mastication is obviously a useful tool, but you just have to know what it does. I think sometimes people are disappointed with mastication after they see the effects where all the trees died, but you have to understand what you get from it. It's more like a fire management tool, it's access tool, rather than necessarily a tool that's going to make your stand more resilient. To make the stand resilient, you also have to deal with the surface fuel, and that's why we started looking at bringing prescribed burning back into these units to deal with that surface fuel. So long-term success, obviously determined by both the rate of decomposition and the rate of regrowth. And if you don't want to create a problem in the long term, you really want to have the rate of decomposition be greater than the rate of regrowth, or you want to be able to think in terms of converting this vegetation type to something that is causing you less of a problem. But I mean, we live in a tough place where we have rapid fuel accumulation. It breaks down slowly, so there's really no easy answers. It's a lot of pros and cons. There's not one treatment you can do that's going to alleviate all of your concerns, and so that's just something that you have to deal with in our area. So I mentioned a few downwoody fuel reduction options, a few ways that we can think about suppressing regrowth. The next talk will give another one, and then finish by talking a little bit about prescribed burning. And like I say, it's something that hasn't been used a lot in masticated units. I think it's something that could be used a lot more based on our findings and findings that other people have had pretty good luck with burning in masticated fuel beds. It can make your burning a lot easier to do. It's certainly a lot easier to light a fire in that kind of fuel than it is to light a fire in a shrub field underneath small trees. You can control the fire behavior a lot better. And you're fine as long as you can control the crown scorch, which you can do through using the appropriate ignition and burning when the soil is still somewhat moist. So I'm just going to leave you with that, and there's a lot of folks who kind of helped out here. I see, Dave, I put your name on here. I didn't know you'd be in the audience, but it's great you're here. So the Joint Fire Science helped fund some of this work. So thank you.
some questions and answers, just in an orderly fashion, with raising your hands here.
I got one right there, and then here.
Eric, it's a little bit discouraging from the standpoint of fire behavior in a masticated unit. You know, we've been promoting use of mastication as opposed to hand treatment, moving the fuels that are hand cut along the roadside, shaded fuel break to the road, chipping them, and actually removing the fuels as opposed to just redistributing the fuels. But it looks like fire behavior doesn't really change if you masticate. And I wonder, you know, if we can, in good faith, promote that practice to the landowners as a means of reducing fire hazard.
Well, I think fire behavior does change. It slows the rate of spread, but what doesn't change is the total amount of heat released. It's the same amount of wood on the ground. So that's what you have to keep in mind. And by slowing the rate of spread, there can be some advantages from the standpoint of fire management, but you just may not be able to maintain all of your trees. It's still going to put a lot of heat into your vegetation. I saw that one next.
Yeah, you know, up here, I mean, we could close our eyes and throw a tree off the window and it's gonna grow, and that's the problem with the masticated units, is they come back so quickly. In a year, it'll be 3 feet high. And so, I was just curious if you've seen anything with the tilling on some of those sprouting species, that it tills up and gets to the roots or anything like that, and that might help with that. Have you seen anything with that?
Well, in the units that we experimentally tilled, the tilling also scarifies the shrub seeds. Bare mineral soil. One thing we noticed is more weeds in the tilled units. And so, again, it's trade-offs. And one thing we did notice, and I don't know, it wasn't that strong, is, but it looked to us that we had some hand thinned units too, where we just cut the stuff off by hand and took it off site. It looked like those resprouted more vigorously than, say, the masticated units, because I think that the masticated material or the machinery, it may have just caused enough of a disturbance of those roots, like when it hit that plant, that it set it back a little bit more than sort of just a hand removal. But
Follow up on that, just to say that perhaps I'd like that, the weeds, because then we'll bring in the browsers and the grazers and deal with those weeds, which they wouldn't tackle the manzanita. So
yeah, it depends on what your concern is. I know some of the weeds we saw were your standard things that came in, like bull thistle and stuff like that. So I'll get.
Dean Cook could probably respond to that chilling issue too.
Yeah, he's got something, and I just wanted to make a comment too on the, one really important thing, when you think about your fuel bed, is the condition that it's in pre. When you go out and look, like for instance, this big fuel break that actually you guys are gonna see, Dale's been working on, that he did a huge mastication project. The pre-fuel condition was dead standing manzanita for 3/4 of the wood. So basically, you've taken dead that's 4 feet high and put it on the ground, a lot of it. And as a fire suppression person, a person rolling up in an engine or a hot shot crew, and you have the flamage coming off, the flame lengths that you get off of dead standing, you can't. It's 6 foot, 8 foot off that manzanita. Whereas now, you put it down on the ground, it's, remember I said lower flame lengths, and they can take a stance. So there's a huge difference there. Yes, it moves into the stand with some of the stuff you showed on the stand as well. It moved into the stand, and you have time lag. When it gets way down in there, it's gonna get big, but you were able to take a stance. You can't do that when you have a solid manzanita brush field. So it's a huge difference. So hopefully people look, when they do their fuel breaks, look at what you got before and after. And at a certain age, and you guys probably know the age when they become that decadent. You know, there's places here that, what, they live 50 years and haven't had fire for a long time. So it's really decadent, we call it.
Well, that's the point of, like, that's what you get when you, with the mastication only. And then if you're able to use prescribed burning in that, then you can deal with that other secondary concern of the heat generated by the remaining wood. And that's why I sort of promote it as like a 2-step process where you can. You know, obviously not, a lot of areas that's not really a possibility. So, I don't know, who's next, but I'll just hit Dave and then I see.
Yeah, just one quick response is that there are thousands of acres over in McLeod lots that have been tilled, but your strategy or whatever you're talking about too, or mastication, until McLeod is now doing joint thing where they'll go in and masticate a unit, especially where they have a lot of fiber targeting plant, and then go to till on top of the mastication unit, and you've got a nice planting bed for their plantations, and yet you still have your browse of grass species to the outside. So anyhow, the cloud is doing a joint mastication and tilling on some grounds.
It might be more possible in areas where you have deep soils like that, so then you have a rocky soils where you can't really do anything with it. So let's go in the back there.
So is there a point in time right after you're done masticating that the chips will decompose enough where they will reduce their fire intensity? I mean, or does that not play a part? Well,
I mean, that's one thing we're going to go back in to look at this summer. We're going to actually look at what the chips look like, how decomposed they are. A lot of decomposed wood isn't really great either because that's like a spotting bed and that creates its own fire problems. Yeah, the idea is to get it decomposed enough that it gets pulled down into the soil and away from combustion. The pictures that I showed, I mean, the sites that we went to 11 plus years after mastication, that wood is still on the ground. And I don't know if it'd be a different story, say if you like masticated some softer wood species like pines or firs, it'd probably be a different situation. A lot of the shrub wood is pretty hard wood and it doesn't decompose very fast.
It helps to have a snowpack on top of it in the winter too.
Yeah. So I saw one here and then I'll go back.
Tomorrow on our field trip after lunch, we're gonna go and look at 2 areas that have been masticated in southwest Mount Shasta. You will see the effects of mastication, the time of the year, and a 1 year apart on one project where before we had a fair amount of precipitation and snowpack, and then at the tail end in April and going into May mastication, where we had very little moisture after that. We have 6 regeneration exam plots that are definitely an eye-opener for the importance of precip and snowpack. Good point, Sheila.
From here.
You brought up weeds, and if you drive north or south from Mount Shasta Boulevard, you see a lot of noxious weeds. I'm wondering if you've done any studies, or if you know any studies about how noxious weeds relate to fire. It said that they burn hotter than native species, because native species are more fire adapted, etc. But I don't know if that's absolutely true.
I think it really depends on the species you're talking about. I haven't seen a lot of research on that. But it really depends on the species, how much moisture they have in their leaves, and how much dead material they hold up in the. Julie was talking about dead manzanita, and that's obviously that's something that's a native species, but that's one fire concern. If say like you have some exotic species come in that are really fleshy, and that may have less of a fire hazard. But yeah, it really depends on the species.
We have time for one more question, then we need to stay on schedule. But we are going to have a panel in the afternoon of our speakers, so we can ask more of these questions, which are great.
So I just had a question about, so there's obviously a spectrum between how quickly regeneration will come in. In the cases where you were doing this pre and post fire monitoring what was killed after mastication, what wasn't, how much of that related to what came back too? Were you able to actually parse that out? Before the burn happened, were you able to see if there was a lot of regrowth? Did it actually make it worse if it was masticated and regrew a lot? Or, was that something that wasn't really like that?
Well, in that particular study, we do have units that we have just masticated and not burned, so we'll be able to follow that. And there's a paper that we've published looking at the short-term effects. One thing we did see is that after burning, we actually enhanced the native flora. There was a greater biodiversity of native species that were kind of suppressed underneath the dense forest or shrub canopy, and they actually came back strongly after the fire. So there were some positives of the burning. And so
I guess I should clarify to the wildfire burning. So where in the very beginning of your presentation, where you were looking at what was killed after mastication, I'm kind of wondering if you masticate an area where it does come back really quickly, are you actually creating a worse condition overall, or did your research look at that, or when you're looking at no statistical difference between whether it was masticated or not? Were you able to actually see how much it regrew before the fire?
I haven't gone, those are sites I've just went to visit right after a fire. I haven't gone back to those since to look at what came back. It would be interesting to do so. Yeah, I haven't done that. Thanks.